So de Moivre's theorem allows us to easily find the value of powers of complex numbers. So rather than having to FOIL or expand using Pascal's triangle or various other things, we can use de Moivre's theorem. So let's have a look and see how that works. Let z equal 2 cis 5 pi on 6. And they've asked us to express z cubed in Cartesian form. So the way we're going to do that is saying, using de Moivre's, and I know I probably pronounce it completely wrong. What that says is that r cis of theta to the power of n is going to be r to the n cis of n theta. So if I'm looking for 2 cis of 5 pi on 6 cubed, which is what I'm looking for, that's my z cubed, I'm going to say, well, that's going to be 2 cubed cis of 3 times 5 pi on 6. And I can simplify that to 8 cis of 5 pi on 2. And my alarm bells start ringing because that's not in my domain for a principal argument, so not in domain. So it's not from negative pi to positive pi. So I first need to turn it into a principal argument. And 5 pi on 2, if I added 2 pi, I'll get pi on 2. Well, I subtract 2 pi, so it's going to be 8 cis 5 pi on 2 minus 2 pi, and that gives me 8 cis pi on 2. Cool. But now they actually want me to put it into Cartesian form, and at the moment it's in polar form. So this is z cubed, but I know that cis stands for cos plus I sine theta. So I can rewrite that as 8 cos of pi on 2 plus 8 sine of pi on 2i. And cos of pi on 2 is 0. And sine of pi on 2 is 1. So z cubed is just 8i.